Hello, welcome to the video for lesson 2, describing the center of a distribution. Okay, so in previous work with data distributions, so we're talking about like 6th and 7th grade, you learned how to derive the mean and the median. So let me just remind you what those are. The mean is the average. If you don't know what that means, average is you add up all the numbers. So if you've got 10 numbers, you add them up and then you divide by how many there are. So 10. The median is you take the numbers and you list them in order from least to greatest and you find the number in the middle. So median is middle. It's the middle value. And mean is the average. This lesson builds on your previous work with a center. Okay, so now we have some different data, sets of data. So data set 1, pet owners. So students from River City High School were randomly selected and asked how many pets do they currently own. And here are all the results. By the way, there are 30 of these. Okay. In data set 2, length of the east hallway, same high school. So 20 students were selected to measure the length of east hallway. 2 marks were made on the hallway floor, one at the front of the hallway, one at the end of the hallway. Each student was given a meter stick, so it's kind of like a yardstick, only it's a little different. It's meters. And then asked to use that to determine the length to the nearest tenth. So they had to basically eyeball it and come close. The results are recorded. So they told you there were 20 students. And then the last data set, age of cars, 25 car owners were asked the age of their cars in years. The results are recorded below. So again, there are 25 of these. Okay. So just a couple of things. So back to the pet owners. It's kind of interesting if you look at these, how the results are. Think about it. Some people might say, well, a cat or a dog counts as a pet. Some people might say, oh, well, I've got a fish tank, so that counts as a pet. Others might say, well, there's 30 fish in the fish tank, so each one is a pet. So there might be a little variance here in what the people consider a pet. As far as the length of the hallway goes, you're using a meter stick, so that's not going to be the full length of this hallway. You've got to, lay it down and then pick it up and then try to pick up where you left off and then keep on going. So there could be a little bit of an issue there. And then when talking about age of cars, some people might think, oh, well, yeah, it's exactly 5 years old to this day. And then one that's, almost 6 years, somebody might still say it's 5 years old. So a year is a lot of time in between. So consider that. Okay, so we're going to make a dot plot for each of these. Essentially what you do is, and it's kind of tricky, I'm going to have to keep kind of scrolling up and down. I'll probably pause the recording. But so number of pets. So I look at how many zeros there are, 1, 2, 3, 4. And I come down here and I'm going to put 4 dots above 0. So 1, 2, 3, 4. Now I got to go back up and check all the ones. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ones. So come back down. Now 1 is going to be in between 0 and 2. So I got to try to line it up with these dots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Almost ran out of room. So I'm going to pause the recording. When we come back, I'm going to have the rest of the data there for you to look at. Okay, and we're back. So I completed this dot plot. Remember, there were 30 students that were asked about this. So What's nice about a dot plot is it gives you a really good visual of the data. And remember, we're going to be looking at things like skewed or symmetrical, and talking about what kind of conclusions or inferences we can draw from what we have in our graph and in the data set. So I want you to do the same thing with the other two sets of data. And then when we come back, we'll take a look at the results you have and mine and compare. Just make sure you check your work and make sure that it's accurate. I'll see you guys in a minute. Okay, we are back. So I finished the dot plots for the other two. Hopefully you did, and yours should look about the same or exactly the same, honestly, because it's pretty simple. Just look at the number and you put the dots above it. Sometimes you may have a situation like the first data set where the scale goes by twos, but obviously there are numbers in between, so you got to be mindful of that. All right, so now we're going to answer some questions based on the data. So calculate the mean number of pets owned by 30 students from River City High School. Calculate the median. So median is not really a calculation, by the way. All right, so we're going to do mean equals and median. Median is just finding that middle, okay? Now, when you've got an even number, that means you have to find the middle two numbers and then find their average. Okay, and I'll explain that in a second. The mean, what you're going to do is you're going to add up all the numbers. So I've already typed them into my calculator. There's a lot of ways you can do that. I'm going to hit enter and I get 96. Now, there's 30 of them, so I got to divide by 30. And I get an answer of 3.2. So I'm going to come back. My mean is 3.2. And my median, so to find the number in the middle, I'm going to go all the way back up to my data set. Now I know it's number 15 and 16 because there's 30 numbers. So if I count over, this is number 15 and this is number 16. So in other words, you count forwards and backwards, and you can kind of cross off as you go, or you can just know that the middle two are the one on the end here and the one on the beginning here, but they're both the same. They're 2. So I come back down and the median is 2. The number in the middle is 2. Okay, let's go ahead and answer question 3. What do you think is a typical number of pets for students from Rivers City High School? Explain why you made your estimate. So here's the deal. Because this data is skewed, the median is the best. I'm actually going to type this. I'm going to pause the recording. I'm going to type it out and then I'll explain. Okay, so let's talk about how to answer this. So if we're trying to figure out what the best or most typical number of pets for a student in this high school is, and we've got these two numbers, mean and median. If I just have the numbers, it's hard to say which one is better. Okay, they're not really that far apart, but 3.2 versus 2, there's still a significant difference. But when I look at the dot plot and I can see that it is skewed, in that there's like this one really high value out here and a couple of these larger ones, and most of the data is over here to the left, that tells me that the average, the mean, is going to be affected by these larger values out here. Okay, so the mean in this case is not a good representation of the data. The median is better because it's in the middle. So essentially, I said the same thing in this. The value of the mean is pulled up by those larger values. Okay, so essentially, and I put this up at the top, if the data distribution is skewed, or if there is an outlier, and that's one of our vocabulary terms, we're going to use the median to help us, with our make our decisions. If it's symmetrical distribution, then the mean is okay, or the mean is the best way to go. However, usually the median is pretty close to that, so either one would be fine. Okay, we actually already talked about number 4. Why do you think there was different results when students measured the hallway? When you lay down, when you're using a meter stick and you have to lay it down and then pick it up and then lay it down and pick it up, there's going to be some error. So we don't need to discuss that. However, what is the mean length of the East Hallway data set and what is the median? So I want you to, let me get the drawing. On your own, find the mean and median. I'm going to pause the recording. When we come back, we'll look at the results. Okay, and we are back. So when you add up all the values and then divide by 20, because there are 20 different values that we're taking, you get 8.57. Now let me just show you how you find the median here. So again, just like before, we are looking at the last value here and the first value here. And you have 8.5 and 8.6. Now, one way you can do when you have two values is you're essentially looking for the average of the two. So we take 8.5 plus 8.6, divide by 2. We hit enter. Oops. Oh, you know what I did there? I should have done the addition first because the calculator doesn't know any better. Then divide by 2, and you get 8.55. So, or some people might recognize that in between 8.5 and 8.6 is 8.55. Okay, so on to the next question. A construction company will be installing a handrail along the wall from the beginning to the end. They want to know how long it should be. What should you tell the company? So they got to round it to the nearest tenth. So basically, is it 8.5 or 8.6? And the answer is, well, it kind of depends. I guess if 8.6 is too long, then they would have to go with 8.5. But we could use either of these. It's kind of funny because this is the answer from the book. It says, since the data distribution is nearly symmetrical, the mean should be used. But if we look at 8.6, it's actually, well, yeah, the mean is closer to that. But either one would round you up to 8.6. So in that case, it really doesn't matter. And a lot of times it won't. But again, if you look at this pattern here, it is a symmetrical data distribution. So we go with the mean unless it was skewed, like the age of the cars. So I've kind of given you a little hint into what's coming next. So let's go down and we just talked about number 7. The distribution of the cars is symmetric. I'll add that to the key. But if you go on to 8 and 9, we're going to find the mean and median, and then we'll talk about the question. So I'm going to pause the recording and answer 7, 8, and 9. When we come back, we'll take a look at the answers together. Okay, really quick, let's just take a look at the answers. So for number 7, the distribution is skewed left. It is not symmetric. Most of the data is on the right with a long tail to the left. So that's how you describe if it's skewed left or right. Here's the mean and the median. The number in the middle is 7. Add them up and divide by 25, and you get 5.84. And then the last one, the median is a better description of the typical age because the distribution is skewed. So if it's skewed, go with the median. If it is symmetric, go with the mean. All right, let's talk about this in class if you have any questions.